Good morning, everyone. So, last class I will discuss about sex determination. Last class I will discuss about sex determination. So, sex determination. What is the sex and what is the sex determination and types of sex determination? So, in 1906, Carl Lorenz proposed theory of heterogenesis. Theory of heterogenesis. According to this theory, there are two types of sex determination: male heterogeneity and female heterogeneity. According to the theory of Carl Lorenz, theory of heterogenesis. According to the theory of heterogenesis proposed by Carl Lorenz, there are two types of sex determination. They are male heterogeneity and female heterogeneity. So last class I will discussed about sex determination in Drosophila. Sex determination in Drosophila. XX and XY method or type of sex determination in Drosophila. XX and XY. So method of sex determination in Drosophila. So in Drosophila, XX and XY. Here the male is heterogametic, female is homogametic. So heterogametic, male is heterogametic. That's why it produces a different. Sperms or different gametes. And female is homogametic, it produces only one type of eggs. This is called XX and XY method of sex determination. And chromosomes. So there are two types of chromosomes, autosomes and allosomes. Then autosomes controls the body characters or somatic characters. That's why they are also called somatic chromosomes or body chromosomes. They are designated as AA. And allosomes, which determine the sex of an organism. Sexual characters. Allosomes control or maintain the sex of the organism or sexual character. That's why they are called allosomes. They are also called sex chromosomes. They are designated as XX in females, XY in males. So all those things. Sex, what is sex? Sex is the hereditary difference. Sex is nothing but the hereditary difference between the two individuals of the same species. And what is the sex determination? Sex determination is the process in which the sexuality of an organism is decided. Sexuality of an organism is decided, is called a sex determination. So all those things I will discuss in the previous class. So sex determination. Sex determination. So last class I have discussed sex determination in Drosophila. Now I have discussed sex determination in man. Sex determination. Sex determination. Sex determination in man. Sex determination in man or human beings. Sex determination in man. Sex determination in man. Sex determination in man. The sex determination in man is XX and XY path or method. In man, the sex determination is XX and XY method or type. Here, XX and XY method of sex determination in man. See here, female is homogametic. Female is homogametic, means similar gametes. Female produces similar gametes. So here X and Y, male produces dissimilar, heterogametic. Dissimilar means heterogametic. Dissimilar gametes are produced in male. They are X and Y. Mainly, the sex is determined by the presence of dissimilar gametes X and Y chromosomes. X and Y chromosomes. Okay. So in man, the sex is determined by XX and XY type. Next, in human beings, in human beings, total 46 chromosomes are present. In human beings, total 46 chromosomes are present. In human beings, how many chromosomes are present? 46 chromosomes are present. There are also 23 pairs. 46 or 23 pairs of chromosomes are present in man or human beings. And they have 44 chromosomes or 23 pairs of chromosomes are present. So male is that is 44 AA plus XY karyotype and female is 44 AA plus XX karyotype. Male is 44 AA designated. A means autosomes. 44 autosomes. And XY 44, 45, 46. Total 46 chromosomes are present in human beings. 46 chromosomes are present in human beings. 44 autosomes, 2 sex chromosomes. 44 plus 2, 46. This is the karyotype of male individual. Next, in female, the karyotype is 44 AA. In female, the karyotype is 44 AA and 2 sex chromosomes means allosomes. Sex chromosomes are also called allosomes. 44 autosomes plus 2 sex chromosomes 46. But here X and Y dissimilar, here similar sex chromosomes, dissimilar sex chromosomes. Total 46 chromosomes are present in female individual also. Clear? So this is the karyotype of female and karyotype of male. So male is heterogametic. Here male individual is heterogametic. Male individual is heterogametic. And produces heterogametic, it produces two different types of gametes or two different types of chromosomes X and Y dissimilar. That's why male individual is heterogametic. Then as a result of this, male individual is heterogametic and it produces two types of sperms. They are first one 22a plus x, and the second one is 22a. So 50%, two types of sperms. So among two pairs, so 50% of sperms, 50% of sperms are 22a plus x, and remaining 50% sperms, remaining 50% sperms are 22a plus 1. 22a plus 1. So male individual is heterogametic. So it produces two types of sperms. It produces two types of sperms. So 50% of the sperm contains 22a plus x. 50% of the sperm contains x, and remaining 50% of the sperms having 22a plus y chromosome. Y chromosome. Clear? And female is homogametic. Female individual is homogametic. Female is homogametic. Female individual is homogametic. That's why female individual produces only one type of egg. Only one type of egg. Only one type of egg. Female is homogametic. It produces similar gametes, X and X. So similar chromosomes. So homogametic. That's why it produces only one type of egg. 22a plus x. 22a plus x. Only one type of egg is produced by the females because females are homogametic. So the sex of the individual or the sex of the offspring, the sex of the offspring is determined. The sex of the offspring is determined at the time of fertilization. You know already, I will explain in the previous class. The sex of the offspring is determined at the time of fertilization. Clear? So it is a sex determination in man. In man, sex determination is XX, XY type. Human beings have 46 chromosomes or 23 types of chromosomes are present in human beings. Male is 40. Male, the karyotype of male individual is 44AA and XY. The karyotype of female is 44AA plus XX. Though male is heterogametic, correct? Male is heterogametic. That's why they produces two types of sperms. Among 50% of the sperms carries X chromosome. Remaining 50% of the sperms carries Y chromosome. So 22A plus X, 22A plus Y. So two types of sperms will produce. So 50% of the sperms carries X chromosome. Remaining 50% of the sperms carries Y chromosome. So here males are heterogametic and females are homogametic. Females are homogametic and they produce only one type of egg. They produce only one type of egg. So they are 22A plus X. So females are homogametic and they produces only 21 type of egg. 22A plus X. So fertilization. So sex of the offspring. Sex of the offspring is determined at the time of the sex of the offspring is determined at the time of fertilization. Sex of the offspring. Sex of the offspring is determined at the time of fertilization. At the time of fertilization. Sex of the offspring is determined at the time of fertilization. Clear? fertilization. Then the sperm, when the sperm fertilizes, when the sperm fertilizes, when the sperm fertilizes with egg, carries, when the sperm fertilizes with egg carries, when the sperm contains X chromosome, when the sperm carries X chromosome, fertilizes with egg, the zygote develops into a female. The zygote develops into female. So clear? Sperm, it's a male gamete. So male is heterogametic. Two types of sperms are produced. One type of sperm contains X chromosome. Another type of sperm contains Y chromosome. Already I will explain. When the sperm carries X chromosome, fertilizes with egg. Egg is homogametic. Similar X and X. Only one type of egg will formed or produced by the female individual. So the sperm contains or carries X, fertilizes with egg. The zygote will develop into female. In other hand, when the sperm carries Y chromosome, when the sperm carries Y chromosome, fertilizes with egg, the zygote will develop into male. The zygote will develop. Egg carries X, sperm carries Y, X, Y. That's why the zygote is developed into male individual. The zygote is developed into male individual. Clear? This is about sex determination in man. So then, hence the sex determination. Hence the sex determination of the offspring in human beings is mainly depends on sperms. Mainly depends on sperms as to whether it carries X chromosome or Y chromosome. X chromosome or Y chromosome. Clear? So the hence in human beings, sex of the offspring is depends upon the genetic makeup of the sperm. Clear? In human beings, the sex of the offspring is determined by genetic makeup of the sperms. As to whether the sperms contain X or Y chromosome. Clear? The sperms decides whether the sperms contain X chromosome or Y chromosome. This X or Y chromosome determines the sex of the offspring. This is called sperm's genetic makeup. Clear? So this type of sex determination is found in all placental mammals. this type of sex determination, is found in all placental mammals and also most of the insects, including Drosophila. Most of the insects includes Drosophila. Most of the insect includes Drosophila. So XX and XY type of sex determination is found in all placental mammals and also most of the insects, including Drosophila. This is the sex determination in man. Here, sex of the offspring is determined at the time of fertilization when the sperm carries X chromosome, fertilizes with egg. The zygote develops into female. X from sperm, X from egg, XX. So the zygote will develop into female. And when the sperm carries Y chromosome, fertilizes with egg, the zygote will develop into male. Because sperm carries Y, X, Y, dissimilar. So the zygote developed into male. So else in human beings, the sex of the offspring is determined by genetic makeup of the sperms. As to whether contains X or Y chromosomes. This type of sex determination is found in all placental mammals and also most of the insects like Drosophila, Melanogaster. Here this is about sex determination in man. Mother, father, father, 44, 44 hydrogen plus XX. Father, 44 autosomes plus XY. P1 generation. Meiosis. See, 22A plus X, 22A plus X. Females mother is homogametic, produces similar or produce similar chromosomes and produces only one type of egg. Both the egg carries same X and X chromosomes. Here in father, but in males, 22 autosomes plus X chromosomes and 22 autosomes plus Y. So 50% of the sperms carries X chromosome, remaining 50% of the sperms carries Y chromosome. Clear? So then 44A plus XX. 44, 22, 44 A. Then 44 AA plus XY. 44 AA XY. Then 44 AA autonomous plus X. Then 44 AA plus XY. 44 AA plus XY. See, this is female. Then male. Then female. Then male. XY, male, XX, female. So this is gametes. So fertilization. Here, this is the sex determination in man or human beings. Clear? Okay. This is the sex determination in man or human beings. Mother homogametic, father heterogametic, then meiosis. So mother produces, means female produces similar or only one type of egg. All the egg carries X chromosome, but here 50% of the sperm carries X chromosome, remaining 50% of the chromosome carries Y chromosome. That is, if males are heterogametic. Then in F1 generation, female, male, female, and male offspring are produced. This is about sex determination in human beings. Next, XX and XO type of sex determination. Second, XO type of sex determination. XO type of a sex determination. See, this type of sex determination, XO, this type of sex determination occurs in or found in the insect like grasshoppers and bugs. This type of sex determination, XX and XO type of sex determination is found in insects like grasshopper and bugs. Grasshopper and bugs. See, here the female is once again homogametic. Produces similar eggs or only one type of egg. Here, male is heterogametic, produces two types of sperms. Yeah. So, the female is homogametic. Female is homogametic and carries X chromosomes. XX chromosomes. Carries XX chromosomes. And male is heterogametic. Male is heterogametic. And carries X and O. O means absence of allosome or absence of partner. Okay. XXXO type of sex determination is found in insect like grasshopper and ducks. Female is homogametic and carries XX chromosomes, and male is heterogametic and carries XO chromosomes and carries XO chromosomes. XO chromosomes. See next. The female produces the egg. The female produces the egg produces the egg with autosome with the female produces egg with autosome. Egg produces autosome with the female produces the egg with autosome and with sex chromosome. And the male produces the sperm. That is two types of sperms. Two types of sperms are produced by the males. One carry among two types of sperms. One sperm carrying autosome and sex chromosome. Clear? So male is heterogametic. We know this is very important. Male is heterogametic. It produces two types of sperms. Male produces sperms, two types of sperm. One type of sperm carry autosome plus sex chromosome. Autosome and sex chromosome. And another sperms carrying autosome, another chromosome carrying autosome plus O without partner. Okay. So female produces egg with autosomes with the sex chromosomes. Then A plus X. Here A plus X. A plus X. A plus X. Male produces two types of sperms, autosome plus sex chromosome, and another sperms carry autosome plus O, means absence of sex chromosome. O means O represents absence of sex chromosome without partner. Two types of sperms. So one is X plus and A O. These are the two types of sperms are produced in the males because males are heterogametic. So hence the sex of the offspring is determined by the sperms, whether the sperms contain X chromosome. Whether the sperm contain X chromosome. Clear? So the sex, because of this reason, so O means absence of sex chromosome. One sex chromosome is absent. That's why the sex of the offspring is mainly dependent upon the sperms, whether it carries X chromosome or O means without allosomes or without sex chromosomes. This is the sex determination in grasshopper and bugs. In grasshopper, the sex determination is XX and XO type. So this is the female homogametic. We know male is heterogametic. That's why it produces only one type of egg, and the male produces two types of sperms. That's why the sex determination is mainly depends upon the sperms carries whether so X chromosome or O. That is absence of sex chromosome. Clear? Next, yeah. Mother of female, male, female, male. A plus X A plus X 0 OXO P1 generation P1 generation then gametes A plus X here A plus X and A plus O is the gametes. Two types of gametes or two types of sperms are produced. So the sperms carries X chromosome and the sperms carries out here the sex chromosome or allosome is outside. Here. Then X then XX then that's XO. This is female. It is male. This is F1 generation. F1 generation. XO male. XX female. This is the sex determination in grasshopper. Sex determination. Sex determination in grasshopper. Sex determination in grasshopper. Sex determination in grasshopper. Here I have discussed. So this is about sex determination in grasshopper. Now I have discussed about sex determination in human beings and the sex determination in grasshopper. Clear? Next is female heterogenesis. Now I have discussed Drosophila, grasshopper and human beings are example for male heterogametic grasshopper, Drosophila and man. These three are example for male heterogameity. Now I will discuss female heterogenesis or female heterogameity. According to theory of heterogenesis, there are two types of sex determination. They are male heterogameity and female heterogameity. So up to here I will discuss male heterogeneity examples. So sex determination in human beings, sex determination in Drosophila, and sex determination in grasshopper. These are the three examples for male heterogeneity. Now I will discuss about female heterogeneity. Female heterogeneity. Next concept is female heterogenesis. Female heterogenesis. Female heterogenesis. Example. Z, W and Z, O. These are the two examples. Z and ZW. This type of sex determination occurs in birds. This type of sex determination occurs in the birds. This type of sex determination occurs in the birds. And then ZZ and ZO. This type of sex determination occurs in butterflies. These are the two examples for female heterogenesis. See here, females. Here, female. So they produce two different gametes, Z and W. Here, male is homogametic. Because male produces similar Z and Z gametes. Here also in butterflies, females are heterogametic. They produce Z and O. But male are homogametic. They produce similar Z and Z gametes or chromosomes. First, I will discuss about Z and ZW. So first one, Z and ZW type of sex determination. First one, ZW type of sex determination. This type of sex determination found in birds. This type of sex determination is found in birds. Okay. Then here the male is homogametic, females are heterogametic. Males are homogametic and females are heterogametic. So this type of sex determination occurs in birds. So to avoid the confusion, so for example ZZ, so X and Y, XX, XY and XX, X0. To avoid the confusion with male heterogametic, ZZ, XX is designated as ZZ and ZW is XY is designated as ZW. Clear? So to avoid the confusion with male heterogameity, XX is designated as ZZ, XY is designated as ZW. Clear? To avoid the confusion. So in males homogametic, and produces only one type of sperms. Only one type of sperms. A plus Z. It is autosome. N is autosome. Z is a sex chromosome. And females are heterogametic. Females are heterogametic. Females are heterogametic. Females are heterogametic. And produces two types of eggs. And produces two types of eggs. And produces two types of eggs. A plus Z and A plus W, A plus W. Two types of eggs are produced because in birds the female is heterogametic. Female is heterogametic. Females are heterogametic. That's why they produces two types of eggs, A plus Z and A plus W. Here, males are homogametic. That's why only one type of sperms are produced, A plus Z. A means autosome, Z, to avoid the confusion. Instead of X, you write, or Z, you write the Z. Means A plus Z. Z is a sex chromosome or allosome. Only one type of sperms are produced, A plus Z. But here females are heterogametic. Females are heterogametic. That's why they produce two types of eggs. So A plus Z and A plus W. So in this case, or in the birds, the sperms carry. The sperm fertilizes. The sperm fertilizes with egg. The sperm fertilizes with egg, carrying Z chromosome. Z chromosome. The zygote develops into. The zygote develops here. Z. Only one type of sperms are produced from males. Here the egg carries Z. So the zygote develops into male. The zygote develops into male. So egg Z chromosome. Here male sperm also Z chromosome. ZZ is a male. Okay. Suppose the sperm fertilizes with. The sperm fertilizes with. The sperm fertilizes with. Egg carries W chromosome. Egg carries W chromosomes. The zygote develops into. The zygote develops into a female. The zygote develops into female. So female Z W. Sperm carries Z. Egg carries W. Z W. The zygote will develop into female. The zygote will develop into female. Clear? Any confusion? So female is heterogametic. That's why two types of eggs are produced. Male is homogametic. That's why only one type of sperms are produced. Suppose sperm fertilizes with egg carrying Z chromosome. The zygote will develop into male. Egg Z and sperm carries also Z. Z male. Then sperm fertilizes with egg carries W chromosome. Sperm Z and egg carries W. That's why the zygote is developed into female. So Z W is developed into female. Clear? This is the sex determination in birds. So it is the best example. Birds are the best example for female heterogeneity. So take down. So male, then female, female, male, A plus Z. It produces A plus Z, and A plus ZW, A plus Z and A plus W, two types of gametes are produced in the females. Gametes, two types of gametes are produced in. Then fertilization, A plus A plus Z. It is male. Then A plus ZW, female. This F1 generation. Here this is the sex determination in birds. Sex determination in birds. Sex determination in birds. Sex determination in birds. Clear? Next, please. Sex determination in butterflies. Sex determination in butterflies. Take note. Now, Z O type of sex determination. Example, butterflies. Example, butterflies. ZO type. See here. So it's also female. Females are heterogametic. They produces two different sex chromosomes, or two different type of gametes, or two different type of eggs are produced by the females. So here females are heterogametic. That's why they produces two different type of eggs. Clear? Male is homogametic. It produces only one type of sperm. See, male, female, male A autosomes plus Z, female A plus ZO, heterogametic. Then A plus Z, then A plus Z and A plus O. This is P1 generation, parental generation. This is gametes. A plus Z. A plus ZO. This is male. This female. This is F1 generation. F1 generation. See, in butterflies, male is homogametic. That's why it produces only one type of sperms, carrying autosome and one X chromosome. That's why only the male produces only one type of sperm or gametes along with autosome. Here, the females are heterogametic. They produce two types of eggs. So carrying autosome and one sex chromosome, and autosome along with absence of sex chromosome. Only autosome is present, but allosome, sex chromosome is absent. Then, so here also the sex of the offspring is determined. Here also the sex of the offspring is determined by the so egg contains the which chromosome? It contains which chromosome? Here this is the sex determination in butterfly. In butterfly, sex determination is ZZ and ZO, and female is heterochromatic. That's why it produces two types of gametes. Male is homogametic. That's why it produces only one type of gametes. Clear? And the sex of the offspring depends upon the chromosomes present in the females or eggs. Here these are the different types of, I have discussed, these are the different types of sex determination. So sex determination in insect, sex determination in birds, sex determination in human beings. Okay. Next class, tomorrow I will discuss the sex determination in honeybee. Sex determination in honeybee. Tomorrow I will discuss sex determination in honeybee. So sex determination in honeybee is also called haploid-diploid method. Haploid-diploid method or haplodiploidy. It's also called haplodiploidy. Okay, thank you. Tomorrow I will discuss sex determination in honeybees.